Everything you have ever touched was left over from the making of one ordinary star. The sun took almost all the matter here, and the rest of it simply stayed behind. Those remnants became the planets, the moons, the rings, and the ground beneath you. Tonight you drift outward through that scattered family toward the widening dark. Nothing out there is in any hurry, and neither for now are you. Tonight, let your body settle exactly where it is, and let your attention drift slowly outward. We are going to travel away from a single star, one you met already in its own long and quiet hour. Now we turn to everything that moves around it. The solar system is not really a collection of worlds. It is one star and the small amount of material that never fell into it. Almost all of the mass here belongs to the Sun. More than 99% of everything in this system gathered inside one glowing sphere. Every planet, every moon, every asteroid, and every comet together make up less than a single percent of the total. Of that thin remainder, most of it is Jupiter, which alone carries more than twice the mass of all the other planets combined. Our own world is a small rounding detail inside that arithmetic, and that is a comfortable thing to know, lying here in the dark. We are not the center of the accounting. We are one of the leftovers, and the leftovers are where the interesting chemistry ended up. Mass is what makes this a system at all. Gravity reaches out from the Sun in every direction, thinning with distance, but never quite stopping. Each planet falls toward the Sun continuously, and each one keeps missing, and that endless miss is what we call an orbit. Nothing out there is held by a rope or a rail, only a curve repeated for longer than you can comfortably picture. All of this began a very long time ago, in a cloud that has been gone for 4.5 billion years. We will come back to that beginning later tonight, and for now it is enough to know that everything here was gathered at the same time, from the same material. The center gathered most of the material, grew dense, grew warm, and eventually began to shine. The rest of the disk was left behind, cooling in wide bands of debris. Grains of dust stuck to other grains, pebbles became boulders, and boulders became bodies heavy enough to pull themselves round. The planets are what remained after the star had finished taking its share. Because everything formed from one flat disk, the planets still travel in nearly the same plane. If you could view the system edge on from far away, it would look almost like a sheet of paper. But flat does not mean crowded. In illustrations, the worlds stand lined up neatly, shoulder to shoulder, all drawn at the same size, while the real arrangement is stranger and far emptier. If the Sun were a ball you could hold in both hands, the Earth would be a grain of sand many paces away. Neptune would be a larger piece, closer to a pea, out past the end of a long street. And between all of them there would be nothing at all for almost the entire distance. Emptiness is the honest texture of this place. Light from the Sun reaches your window in about 8 minutes, and that same light needs more than 4 hours to arrive at Neptune. It carries on outward after that, growing fainter, still traveling, still unopposed. Distance decided what each world became, and the reason for that will come much later tonight. For now it is enough that the near worlds came out small and dense, and the far ones came out enormous and soft. Farther out, past a line where water could freeze into solid grains, there was far more building material available. The outer planets grew enormous, gathering hydrogen and helium into atmospheres thousands of kilometers deep, with no solid ground waiting underneath. Same origin, same cloud, same chemistry. Only the distance from the fire was different, and that alone shaped everything else. Beyond the outer planets, the worlds simply grow scarcer, and the light that finds them grows thinner with every step outward. Bodies simply become smaller, colder, and more widely separated, until they are almost impossible to notice at all. Even those faint outer objects are still turning around the same center, taking thousands of years to complete one slow lap. There's a further scale above this one, since the whole family, star and planets together, is moving through the galaxy at the same time. One circuit around the galactic center takes something close to 230 million years. The last time the sun stood in this part of its path, the earliest dinosaurs were only beginning to appear. Everything you will hear tonight is riding along on that longer, slower curve. Over the coming hours, we will drift outward, one world at a time. We will begin in the heat close to the star and end far out in the cold where sunlight is little more than a bright point. There's nothing here you need to hold on to, and you can let the names slip past you without any effort. The system will keep turning whether or not you follow it, and so will you. Right now, above the roof over your head, every planet is quietly falling around the same star. None of them will arrive. They have been falling for 4.5 billion years, and tonight is no different from any other night in that long sequence. Let your breathing slow down a little. We are going to start at the center, close to the light, and move gently outward from there. Break chapters 2 and 4 through 16 into blank lines separated paragraphs of roughly 100 words each, matching the paragraph formatting already used in chapters 1 and 3. Mercury and Venus never stray far from the glare, so they appear low and brief in the last blue of evening or the first gray of morning. Venus is the bright one, steady and calm, the lamp that people once called a star of the evening and a star of the morning. Mercury is fainter and shyer, a small ember that sinks quickly into the horizon. Both of them are rocky, both are small, and both are hot. Yet the way each one holds its heat could hardly be more different. Mercury has almost no atmosphere at all, only a thin haze of atoms so sparse that it barely deserves the name. Sunlight falls onto bare rock, and the rock drinks it directly. On the side facing the sun, the surface climbs to about 430 degrees Celsius, hot enough to melt lead. Then the ground turns away and there is nothing left to hold the warmth. No blanket of air, no ocean, no weather, nothing to carry heat from the day side to the night side. the temperature falls to about minus 180 degrees. Mercury is therefore one of the hottest places in the solar system and one of the coldest, depending only on where you stand and when. The sky above it stays black even at noon, because there is no air to scatter the light into blue. There is no wind there, and no sound and no softening of anything. Near the poles of Mercury there are craters whose floors have never once seen the sun. Because the axis of that planet barely tilts, those floors sit in permanent shadow and they stay below minus 170 degrees. Water ice has survived inside them for a very long time, and a spacecraft called Messenger confirmed this in the year 2012. So on one small world, ground hot enough to melt metal lies only a few meters from ice that has been frozen for billions of years. Nothing separates them but a rim of stone and a line of shadow. Another visitor is on the way. A mission called Bepi Colombo is on its way there now, and it will settle into orbit around Mercury and map that shadowed ice from close range. Venus is the next world outward, almost twice as far from the Sun. By simple distance it should be the cooler of the two, but it is not cooler at all. The surface of Venus rests near 460 degrees Celsius, hotter than the hottest ground on Mercury. Averaged over its whole long day and night, Mercury is barely a third as warm as that. And unlike Mercury, the heat on Venus does not move. Day or night, equator or pole, lowland or highland, the temperature barely shifts. The reason is not where Venus sits. The reason is what Venus wears. Roughly 96 parts in 100 of that atmosphere is carbon dioxide, and the whole envelope presses down with enormous weight. Sunlight filters through the cloud deck and warms the ground, and the ground radiates that energy back upward as infrared heat. The thick carbon dioxide absorbs it, holds it, and returns much of it to the surface, so very little escapes to space. Century after century, the warmth accumulates until the whole planet settles into one slow oven with no cool corner anywhere. This is the greenhouse effect, taken to its limit. Venus may not have begun this way. There is a reasonable case that liquid water once lay on its surface, early in the history of the solar system. As the young sun brightened, that water rose into the air as vapor. Water vapor traps heat as well, so the air grew warmer, and warmer air lifted still more vapor. The process fed itself, and the thick air it built is still there today, and we call that a runaway greenhouse. Venus is the only example near enough for us to visit. What you see when you look at Venus is not the ground at all. It is the top of a cloud layer that covers the planet completely and never opens. Those clouds are not made of water, but of sulfuric acid droplets, high and cold, drifting far above the hot rock below. They are also very bright, which is why Venus shines so calmly in your sky. Beneath them, the surface stayed hidden for the whole of human history. Only a handful of landers ever reached it and sent pictures back. They worked for a short while and then went quiet, having sent back everything they were built to send. What they returned was quiet and unremarkable, a plain of flat broken rock under a dim orange sky, lit like a late afternoon. No fire, no storm, only stillness and weight. Radar has since traced the rest of that landscape from orbit through the clouds in long, patient strips. So these are the two small hot worlds nearest the sun. One is bare and keeps nothing. The other is wrapped and lets nothing go. Between them they teach the same quiet lesson, that warmth depends less on distance from a star than on what a world is able to hold. Tonight, when Venus stands low and steady above the horizon, remember that the calm light you see is only the top of an unbroken cloud, and that the ground far beneath it is glowing softly in the dark. The third world from the sun is the one beneath your feet. It is easy to forget that Earth is a planet at all, because you live inside the view and never see the whole of it. For nearly all of human history, nobody did. Then a few travelers went far enough to turn around and look back. In the December of 1968, 3 people flew around the far side of the moon. They were watching gray ground scroll past below them, photographing craters and naming them as they went. Then one of them looked up and saw the Earth coming over the lunar horizon, blue and white and half-lit, small enough to cover with a thumb. The photograph they took is still one of the quietest images ever made. It is worth knowing that the Earth does not really rise on the moon. The moon keeps one face turned toward us, so from the near side our planet hangs almost still in the sky. It wobbles a little and it changes phase, but it does not climb, and the Earth rose that morning only because the spacecraft was moving. The rising belonged to the travelers, not to the sky. From that surface, our world would be a strange kind of lamp. It would look about 4 times wider than the moon looks from your window, and it would hold its place above one patch of gray dust for as long as anyone stood there. Its light would fall across the lunar night, soft and blue, bright enough to see the ground by. 4 years after that first photograph, another crew caught the planet fully lit. The sun was directly behind them, so no shadow crossed the disk at all, and Africa lay near the middle under bands of cloud with the southern ice turned toward the camera. They called it the Blue Marble, and the name stayed. There is no top and no bottom out there. The picture was later turned the other way up, simply because that is how we are used to seeing ourselves. The color has 2 separate sources. Most of the surface is ocean, and deep water absorbs the warm end of sunlight and gives back the cool end. The air does something similar in a different way, since air molecules scatter short wavelengths far more strongly than long ones, which is why the sky above you glows blue in every direction. Seen from outside, that same scattering becomes a thin, bright rim drawn along the edge of the planet. That rim is the detail that surprises almost everyone who has been up there. Nearly all of the air sits in a layer less than 1/100th of the way down to the center, and every cloud, every storm, every bird, and every breath happens inside that line. Above it there is no hard edge, only a slow thinning into almost nothing. Astronauts describe a soft band, brightest near the ground and fading upward through violet into black. Then the planet turns, and you follow it into the night. The boundary between day and night has a name, the Terminator, and it is far gentler than you might expect. Sunlight bends and scatters through the air ahead of it, so the edge is a wide band of dusk rather than a line. On the dark side, the cities come up. They arrive as small warm knots of light, joined by thin threads that follow roads and rivers, and coastlines draw themselves in gold, because that is where people have always settled. Inland, the light thins quickly. Most of the night side stays dark, and fishing fleets scatter faint points across the open ocean far from any shore. Lightning flickers under the cloud tops, many times every second, silent from that height. Near the poles, the aurora hangs in slow curtains above the weather and often below the spacecraft. None of the lines we draw on maps appear anywhere in the picture, and you can see rivers and mountains and the brown edges of deserts, but no borders. From farther out, even the cities vanish. When Cassini turned its cameras back toward home from beside Saturn, the Earth was a single pale point beneath the rings. Every person who has ever lived was inside that point of light. There is one more thing that only shows itself from outside. Earth is the only world we know of where liquid water is stable in the open at the surface. It is not all locked into ice, and it has not been lost to space, but sits in shallow basins under an atmosphere just heavy enough to hold it down. That balance is the whole reason the planet looks the way it does. The white is water that has risen. The blue is water that has settled. The thin, bright line around the edge is the reason both of them can stay and the planet keeps turning, carrying the dawn westward across one dark ocean after another. Somewhere on the night side, a coastline is drifting slowly toward the light, and in a few hours the people there will wake and look up at a sky that seems like a ceiling. From out there, it is not a ceiling at all. It is a thin blue shell, and you have only ever seen it from the inside. Mars is the fourth world out from the sun, and it is the one that most resembles a place where you could stand. It is smaller than Earth, a little more than half as wide, with a land area close to that of all the dry continents of our own planet. The whole of it is the color of dried rust. That color comes from iron in the soil, oxidized slowly across billions of years into fine reddish grains. The dust is finer than beach sand, closer in texture to smoke or to flour. It settles on everything, on the rocks, on the slopes, on the panels of every machine we have ever sent there. The air above that dust is very thin. At the surface, the pressure is less than 1/100th of what you feel at sea level on Earth. The atmosphere is mostly carbon dioxide, the same gas that smothers Venus, but here there is so little of it that it holds almost no warmth at all. Venus and Mars breathe the same gas and arrive at opposite results. One is an oven, the other a freezer, and the difference is simply how much air there is. On a summer afternoon near the equator, the ground can climb close to the freezing point of water. By the middle of that same night, it has fallen to around -80 degrees or lower. Thin air cannot hold heat. That thin air still carries dust, and the dust changes the light. During the day, the sky above Mars is a soft butterscotch, a pale tan that spreads all the way to the horizon. Around the setting sun, the color reverses, and a cool blue glow gathers close to the disk while the rest of the sky stays warm. It is the mirror image of our own evenings. Both poles wear caps of ice. Underneath lies permanent water ice, layered like the pages of a book with dust from older seasons. Over the top of that, each winter, carbon dioxide freezes directly out of the atmosphere and settles as a bright frost, then returns to gas when the light comes back. A meaningful share of the whole atmosphere takes part in this exchange, so the planet breathes in and out once a year, slowly from one pole to the other. The land beneath is older and quieter than almost anything on Earth. Olympus Mons rises about 22 kilometers above the surrounding plain, taller than any mountain our own planet has managed to build. Its base would cover a small country. Yet the slopes are so gentle, only a few degrees for most of the climb, that walking up it would never feel like climbing a mountain. The horizon would simply keep retreating. Only at the outer edge does the volcano announce itself in a cliff standing kilometers above the plain. Not far away lies Valles Marineris, a system of canyons stretching more than 4,000 kilometers deep enough in places to swallow 7 kilometers of rock. It was not carved by a river. The crust appears to have stretched and pulled apart, and the walls then collapsed inward over an immense span of time, widening the trench with one landslide after another. Water left its signatures elsewhere. In the ancient southern highlands there are valley networks that branch the way rivers branch, gathering from many small threads into fewer large ones. There are fans of sediment where those threads once slowed and set down what they carried. In Jezero Crater, the Perseverance rover found layered deposits and worn surfaces that confirmed exactly this, an old river delta, quiet now beneath the dust. The delta dates to more than 3.5 billion years ago, an early chapter in the story of Mars. Instruments on the rover detected magnesium carbonate, a mineral that forms where water and carbon dioxide meet and react. The rocks of Jezero record 3 separate phases of water, beginning with acidic fluids, passing through more neutral conditions, and ending in waters that were alkaline. The chemistry changed while the water was still there. In the middle of 2024, the same rover reached a stone named Shayava Falls and found markings across it that resemble the spots of a leopard. On Earth, patterns like these can be left by microbes moving chemistry around inside wet sediment. On Mars, the finding is treated as a possible biosignature and nothing more, an interesting arrangement of minerals that still waits for a laboratory. Elsewhere in Gale Crater, the Curiosity rover has shown that ancient dunes were slowly cemented into stone by groundwater seeping between the grains. The wind built them, and the water made them permanent. All of that is finished now. The rivers stopped, the air thinned, and the surface settled into a long, dry stillness. What remains is motion of a very patient kind. Dust lifts on a light wind, drifts a while, and comes down again a little further along. Small whirlwinds wander across the plains and leave dark tracks where they have swept the loose grains aside. In the shadow of a rock on a cold morning, a thin film of frost can gather and then vanish as the sunlight reaches it. The same wind has been rearranging the same dust for a very long time. Nothing there is in any hurry. Between the orbit of Mars and the orbit of Jupiter, the solar system leaves a wide and quiet gap. For a long time, astronomers looked at that gap and expected something to be waiting there. The spacing of the planets seemed to follow a gentle rhythm, and one step of that rhythm was missing. Then, at the very beginning of the 19th century, a faint point of light appeared in exactly that region. It was named Ceres, and for a while it was counted as a planet. Soon another was found, and then another, and then hundreds more. The missing step in the rhythm was not missing at all. It held a scattered swarm of small worlds. We call that swarm the asteroid belt, and the name has quietly misled almost everyone who hears it. The word belt suggests something dense and continuous, a river of stone circling the sun. Films have deepened the confusion, filling the screen with tumbling boulders that a pilot must weave between its speed. The truth is calmer, and in its own way far stranger. The asteroid belt is mostly empty space, and the distances inside it are worth sitting with for a moment. The average separation between bodies in the main belt is close to 1 million kilometers. That is more than twice the distance between the Earth and the Moon. If you count only the asteroids larger than a kilometer across, the typical spacing grows to millions of kilometers. Imagine standing on the dark surface of one of them under a sky that would be black and thick with stars. Your nearest neighbor would be somewhere out there, and picking it out with the unaided eye would be a matter of luck. You could stand there for a lifetime and never watch a single rock drift past. Spacecraft have confirmed this emptiness directly, because every probe sent to the outer solar system has passed straight through the belt. Not one of them performed a single avoidance maneuver. The odds of striking anything on the way through are estimated at less than 1 in a billion. Engineers plan the crossing the way you might plan a drive across an empty plain. The belt is thin in another sense as well. If you gathered every asteroid in the main belt into one body, the total mass would come to only a few % of the mass of the Moon. That small amount of material is spread through a volume so vast that the mind refuses to hold it. Ceres alone accounts for more than a third of everything in the belt. It is round, roughly 900 kilometers across, and heavy enough for its own gravity to have pulled it into a sphere. Beneath the dusty surface, Ceres may carry a thick mantle of ice resting on a rocky interior. The second great body of the region is Vesta, and it is a different kind of world entirely. Vesta is dry and layered, with a metal core, a rocky mantle, and an ancient volcanic crust. A single spacecraft called Dawn visited both of them in turn, and the contrast between the two is the real story of the belt. One is icy and one is stony, and they formed in the same wide neighborhood. The obvious question is why all of this material never gathered itself into a planet. Planets grow by gentle contact. In the young disk around the Sun, small bodies drifted at similar speeds and touched softly, and each touch left them a little larger. That process only works while the relative speeds stay low. Jupiter is what changed the arithmetic of that region. Jupiter formed early and grew enormous, and its gravity reached deep into the region just inside its own orbit. It stirred the local orbits, stretching them and tilting them out of their calm alignment. Bodies that had been drifting side by side began meeting at speeds of several kilometers each second. At those speeds, a meeting no longer builds anything, it takes things apart. Instead of sticking together, the bodies broke one another into smaller and smaller pieces. Much of the original material was thrown out of the region entirely, sent inward toward the Sun or outward past Jupiter. What survives today is a modest remnant of what once filled that space. There is a second signature of that influence, and it is written into the spacing of the orbits themselves. At certain distances from the Sun, an asteroid completes exactly 2 or exactly 3 circuits for every single orbit of Jupiter. Those rhythms repeat, and a repeated nudge from a giant planet is a patient and powerful thing. Over long stretches of time, the bodies at those distances are eased away, leaving narrow lanes swept clean. The lanes are invisible in the sky, and they show up only in the quiet tables of orbital periods. Nothing in that region had to be destroyed to make the belt, because there was never a planet there to break. The belt is not the wreckage of a lost world. It is a construction site that was never allowed to finish. The material simply stayed as it was, scattered and unassembled, holding its earliest chemistry for 4.5 billion years. So when a spacecraft crosses that region now, almost nothing happens, and the cameras see nothing but stars. The Sun grows a little smaller behind, the cold deepens, and the belt slips by without a sound. Jupiter turns faster than any other planet in the solar system. A single day there lasts a little under 10 hours. That speed pulls the clouds into long lanes that wrap the entire world. Astronomers call the pale lanes zones and the darker lanes belts. In the zones, gas is rising and cooling into bright ammonia cloud. In the belts, gas is sinking and warmer layers show through in shades of brown and rust. Between every belt and every zone, there is a seam where the winds run in opposite directions. Those seams are where the weather of Jupiter becomes visible to you. Small eddies form along them, drift, merge, and slowly fade. Most of them last a season or two. One of them has lasted longer than most empires on Earth. The Great Red Spot is a high-pressure storm turning in the opposite sense to the low-pressure systems you know at home. It completes one full rotation in roughly 4 to 6 of our days. People have watched it steadily for at least 150 years. In all that time, it has been getting smaller. Near the end of the 19th century, observers measured it at about 41,000 kilometers across. When Voyager 2 passed by in 1979, the spot had narrowed to some 23,300 kilometers. By 1995, Hubble measured it at close to 21,000 kilometers. The narrowing has continued since then, quietly, decade after decade. Even so, it remains wide enough that the whole Earth would fit inside its outline. The storm is not dying, it is only changing its shape. As it loses width, it grows taller, and it drifts a little faster around the planet. Between December of 2023 and March of 2024, Hubble watched the spot closely enough to notice something new. It was slowly breathing in and out. Over a cycle of about 90 days, it swelled and eased again, like something soft resting in a loose hand. Researchers do not expect it to vanish. They expect it to settle into a rounder, steadier form and go on turning. For a long time, nobody could say how deep that storm reached. On Earth, weather is a thin film, a few kilometers of moving air resting on solid ground. Jupiter offers no such floor, and the planet has no solid surface at all. If you descended through the cloud tops, you would never land on anything. The gas would simply thicken around you until it behaved like a liquid with no boundary you could point to. The Juno spacecraft measured the gravity of Jupiter precisely enough to weigh the winds themselves. The banded winds you see from outside reach roughly 3,000 kilometers down. That is deeper than the entire atmosphere of any rocky world, and it is still only the outer skin here. Below that depth, something changes. The interior stays fluid, yet it rotates together as one body as though it were solid. The bright stripes simply end there, and beneath them the planet turns as a single piece. For centuries we saw Jupiter only from the side near its equator. Juno was placed in an orbit that carries it over both poles. What waited there does not resemble the striped face in the old photographs. The bands break apart near the poles and give way to clusters of enormous cyclones. 8 of them ring the North Pole, arranged around a 9th storm sitting at the center. The South Pole holds 5 in a ring around a 6th. Each one is a spiral wider than many countries, and they hold their positions year after year, crowding against one another, nudging, then settling back without ever merging. Nothing on Earth arranges itself in that pattern. In the Juno images, they look almost painted, pale spirals on deep blue, more like brushwork than weather. Around all of it lies a magnetic field unlike any other among the planets. It is generated in a layer of hydrogen so compressed that it conducts electricity like a metal. The field that emerges is the strongest of any planet in the solar system. It sweeps a vast invisible bubble through the wind of charged particles flowing out from the sun. If that bubble glowed and you could see it from your garden, it would look wider than the full moon. Juno found the field to be uneven, stronger in some regions than others, with a narrow band near the equator where it plunges inward. The same field gathers charged particles and guides them down toward the poles. There they feed auroras far larger and far more constant than the ones that visit our own skies. Those lights never fully rest because Jupiter powers them from its own spin and from gas escaping its volcanic moon. Come back to the spot one last time before we leave it. It was already turning before anyone thought to point a lens at the sky. Kingdoms have risen and closed while that single weather system kept its slow rotation, 4 to 6 days for every full turn. There is no coastline to break it, no mountain range to slow it, no winter strong enough to end it. It simply narrows a little each decade and continues. Right now, in the dark on the far side of that planet, it is still turning. Saturn is the planet almost everyone can draw from memory. Even a child who has never looked through a telescope knows the shape, a pale globe wearing a ring. The rings are the reason, and they are far stranger than the drawing suggests. When Galileo first turned his small telescope toward Saturn, he could not resolve them at all. He saw a planet with 2 companions, one on each side, and he called them handles. A few years later, the handles simply vanished, and he wondered whether the planet had swallowed its own children. What had really happened was that the rings had turned edge-on to our line of sight. That vanishing is the first honest clue about what the rings actually are. They disappear because they are almost unimaginably thin. Across their bright span, the main rings measure roughly 270,000 kilometers from one outer edge to the other. Over that immense width, they are in many places only about 10 meters thick. Imagine a sheet of paper wide enough to cover a city block. The rings are flatter than that by a wide margin, and the sheet is not solid at all. For 2 centuries, astronomers argued about whether the rings could be a single rigid disk. James Clerk Maxwell settled the matter with mathematics rather than a telescope. He showed that any solid ring of that size could never hold together against the gravity of the planet it circled. The only stable answer was a swarm of countless separate bodies, each one following its own orbit. Later measurements confirmed exactly that, and more than 95% of the ring material is ordinary water ice. The remainder is dust, rocky fragments, and darker compounds mixed in thin traces. So the most famous ornament in the solar system is essentially frozen water, endlessly reflecting sunlight. The pieces range from grains finer than sugar to boulders the size of a small house. They are extremely cold, sitting near 200 degrees below zero. They do not tumble at random, and each one obeys the same patient gravity that governs the moons. Nearer the planet, particles complete a lap in a few hours, while the outer ones take far longer. Because neighbors travel at nearly the same speed, their collisions are gentle, softer than a walking pace. If you could hover just above the ring plane, it would look like a slow snowstorm that never reaches the ground. From far away, the rings appear to be grooves cut into a record, and those divisions are real, carved rather than painted. The widest of them is kept open by the small moon named Mimas. A particle orbiting in that gap completes 2 circuits for every single circuit Mimas completes. The gentle tug therefore arrives at the same place every time, and over the ages it empties the lane. Other gaps contain a tiny moon of their own, sweeping the path clear as it travels. The narrow rings are stranger still because they are held together by pairs of moons called shepherds. One shepherd orbits just inside the ring, and one orbits just outside. The inner moon moves faster and nudges wandering particles forward, while the outer moon moves slower and pulls them gently back. Caught between the two, the ring stays narrow and sharply defined. It is tempting to assume that something so orderly must be permanent. Nothing about the rings is permanent. In its final orbits, the Cassini spacecraft dived through the gap between the cloud tops and the innermost ring. It measured the material falling inward, and the flow turned out to be substantial, somewhere between thousands and tens of thousands of kilograms every second. Only about a quarter of that falling material is water, and the rest is methane, carbon monoxide, nitrogen, ammonia, carbon dioxide, and small organic particles. Gravity draws the finest grains down, and the magnetic field of the planet guides them along its lines into the upper atmosphere. Astronomers call the process ring rain. At the present rate, the rings could be exhausted in something like 100 million years. That is an enormous span by human measure, and a brief moment by planetary measure. Saturn itself has existed for more than 4 billion years, and seen in that light, the rings are a passing season rather than a fixed feature. Their age is still genuinely argued over, and measurements of the dark dust settling onto the ice suggest an exposure of only 100 to 400 million years. A more recent study countered that the rings might be as old as the planet, kept bright by processes that clean them. Both answers remain on the table, and the honest position is that we do not yet know. Either way, we happen to be watching during a narrow window. Saturn leans over as it travels, so the rings tilt toward us and then away again. Twice in every orbit they turn edge on, and for a short time they nearly disappear, exactly as they did for Galileo. Then they open once more, and the thin bright line returns. Point a modest telescope toward the planet on a still, clear night, and you can see it yourself. A small yellow disk, and around it a separate ring of light with darkness on either side. The light entering your eye left that ice more than an hour earlier, and it crossed all that cold distance carrying the reflection of countless drifting fragments. And every one of them is quietly, slowly on its long way down. Far from the sun, where sunlight arrives thin and pale, water still moves. It does not move on the surface. The surface out there is ice, hard as rock at temperatures that low, and the motion is all underneath, in the dark where it has very likely been going on for a long time. Two small worlds show that hidden water most clearly, and both of them orbit giant planets. One circles Jupiter and is called Europa, and the other circles Saturn and is called Enceladus. Europa is close to the size of our own moon, and it is smooth in a way that is unusual for an old world. When the Voyager probes and later the Galileo orbiter sent back images, the first thing observers noticed was the absence of craters. An ancient surface should be scarred, marked by every impact it has collected across billions of years. The face of Europa is almost clean, so something has been erasing the record. Instead of craters, the ice is covered in long dark lines that run for thousands of kilometers. They cross each other, curve gently, and in places double back like the seams on a cracked shell. These lines are fractures, and they open and close as Jupiter pulls on the moon. Europa travels on a slightly stretched orbit, so the pull it feels rises and falls each time around. The whole body flexes a little closer to a sphere, then a little less, and that flexing generates heat deep inside, quietly and continuously. Heat is what keeps water liquid where the sun cannot reach. There is a second clue, and it comes from magnetism. Jupiter carries an enormous magnetic field, and Europa moves through it constantly. A layer of salty water conducts electricity, and a conductor moving through a changing field answers with a field of its own. The Galileo spacecraft measured exactly that answer, and the induced field matched what a global salty ocean would produce. We have never seen this ocean, but we have watched it respond. In 2023, the James Webb Telescope found carbon dioxide on the surface of Europa. The interesting part was where it sat. The carbon dioxide was concentrated in a region of broken, jumbled ice rather than spread evenly across the moon. That pattern suggests the carbon came up from the ocean below instead of arriving from outside. Regions like that are called chaos terrain, and they look much as the name suggests. Blocks of crust sit tilted and rotated as if a solid raft had broken apart and then partly refrozen, and something soft was underneath while it happened. Enceladus tells the story differently, because Enceladus shows you the water directly. It is a small moon, small enough that you could drive around it in a few days if there were roads. Near the South Pole, 4 long fractures cut across the ice, and from those fractures material rises. Those fractures are warmer than the ice around them, which is how the heat of the interior gives itself away from a great distance. Cassini flew through the plume more than once, tasting it as it passed, and found mostly water vapor with fine grains of ice, much of which falls back down. The rest escapes and feeds one of the faint outer rings of Saturn. A moon is quietly leaking into the space around its planet. That ring is so thin that a spacecraft can pass straight through it without trouble, and yet every grain in it began as ocean water beneath the southern ice. What Cassini found in those grains has kept researchers occupied for years. There was salt, which points to an ocean in contact with rock, and there were fine grains of silica whose size suggests warm water reacting with mineral surfaces. On our own planet, that kind of chemistry happens around hydrothermal vents on the seafloor. Then, in an analysis published in 2023, phosphorus turned up in the ice grains. Phosphorus is one of the elements that life here cannot do without, and it had never before been detected in an ocean beyond our own. The measured concentration was at least 100 times higher than in the seawater of Earth. It is worth being careful here, because salt, warmth, carbon, and phosphorus describe an environment and not an inhabitant. Ingredients on a counter are not a meal. Nobody has found life in either ocean, and no instrument yet flown was built to settle that matter. What has been found is that the conditions are less strange than we once assumed. That is a quieter result, and it is still a large one. The plumes themselves are not steady, and when Webb looked at Europa, it saw no active jet at that moment. Whatever venting happens there appears to come and go rather than run without pause. Enceladus is more reliable, though its output rises and falls as it travels along its orbit. The fractures seem to squeeze and relax, letting more or less material through. Under the ice of Europa, the water may be tens of kilometers deep. It would be dark, salty, and slowly stirred by heat rising from the rocky floor below. There would be no waves because there is no wind and no open sky. Only a ceiling of ice, cracking somewhere far away, and the faint groan of that motion carrying through the water. Above it, the surface holds still under the pale light of a distant sun, and the moon goes around its planet again, flexing gently, keeping the ocean warm. From far away, Titan gives away almost nothing. It hangs beside Saturn as a soft orange sphere, smooth and featureless, wrapped in a haze that hides every detail of the ground below. The two Voyager spacecraft flew past and sent home images of a blank amber ball. For a while, the atmosphere simply won. That haze is made of complex organic molecules, built when sunlight and charged particles break apart methane and nitrogen high above the surface. The fragments recombine into heavier compounds, and those compounds drift slowly downward as a fine orange smog. A single particle can take years to reach the ground. Beneath that veil, Titan is the only world besides Earth known to hold stable liquid on its surface. There are lakes there, and seas and rivers that carved their valleys the ordinary way by running downhill for a very long time. None of that liquid is water. The surface sits at about minus 180 degrees, cold enough that water ice behaves like stone. The mountains and the riverbeds and the gravel are all made of ice so cold it has forgotten how to melt. The liquid is methane and ethane, the same simple carbon compounds that arrive on Earth as gas. On Titan, they fall as rain. Clouds gather in the upper atmosphere, drift over the poles and release drops far larger and far slower than any raindrop you have watched from a window. The air at the surface is about half again as thick as the air you are breathing now, and gravity there is roughly 1/7 of what holds you in your chair. A drop of methane falls through that combination at about the pace of settling snow. Rain is rare in any one place, but when it comes, it soaks the ground and gathers into channels. Those channels feed the northern seas. Ligeia Mare, one of the large northern bodies, appears to be mostly methane. Kraken Mare, larger still, seems to hold a greater share of ethane. Some of the smaller lakes are around 90 meters deep, and several of them sit in steep basins with no rivers running in. The evidence suggests they are filled from below by reservoirs held inside the icy crust. Near the equator, the ground turns dry, and long, dark dunes of organic sand run for hundreds of kilometers, combed into parallel ridges by winds that would barely lift a scarf. Titan has a working weather system, complete with evaporation, cloud, rainfall, and drainage. It simply runs on a different chemistry than yours. The seasons out there last about 7 years each, because Saturn takes roughly 3 decades to make one circuit of the Sun. In the year 2005, a small probe named Huygens fell through that haze for about 2.5 hours. It swung beneath a parachute while its camera looked down through thinning orange light. What appeared below was a landscape anyone from Earth would have recognized at once. Dark branching channels came down out of pale highlands and emptied onto a flat plain. They forked and narrowed exactly the way streams do. There was a shoreline, and past it a darker region that had once held liquid. Huygens landed on that plain with a soft thud and settled a little way into the ground. The surface underneath behaved like damp sand. Scattered around the probe lay rounded pebbles of water ice, smoothed and sorted by a fluid that had tumbled them along. As the warm instrument rested there, methane rose out of the soil as vapor. The ground was still wet. The probe sent data for about 70 more minutes, and then went quiet, and nothing has landed there. That is going to change before long. A rotorcraft named Dragonfly is due to arrive in the year 2034, and it will fly from one landing site to the next across those dunes. Far closer to the Sun, another moon runs on heat instead of cold. Io orbits Jupiter, and it is the most volcanically active body known in the solar system. Hundreds of active volcanoes are spread across a surface with no impact craters at all, because fresh material buries them faster than they can collect. The energy comes from tides. Io is pulled one way by Jupiter and tugged the other way by the neighboring moons, so its interior is kneaded without pause and never allowed to cool. Data from the Juno spacecraft suggests that the volcanoes of Io are not fed by a single global ocean of magma. Each one seems to draw from its own separate chamber, a private reservoir beneath a private mountain. In late 2024, Juno watched a hot region wider than Lake Superior begin to glow, and it was still glowing months afterward. The colors come from sulfur. Sulfur compounds erupt, spread across the plains, and freeze into yellows, oranges, reds, and pale whites depending on how quickly they cooled. Frost of sulfur dioxide drifts back down and settles as a thin, bright powder. Many eruptions leave a broad ring of fresh deposit around the vent, and older rings fade quietly under newer ones within a few years. Two moons, both restless, both painting themselves in a chemistry we do not have here. One works in warm mineral color, the other in cold amber light. Somewhere on Titan tonight, in a glow the color of weak tea, a single drop of methane is falling toward a shore of ice. It will take a long time to land. Far out in the cold outer reaches of the planetary family, a pale disk turns on its side. Uranus is the world that lies down. The axis of Uranus is tipped by roughly 98 degrees, so the planet rolls along its orbit instead of spinning upright like its neighbors. Every other large world here spins more or less like a top. This one spins like a ball rolling slowly down a very long hill. The reason it lies this way is not known with certainty. That uncertainty is worth resting in for a while. The most familiar explanation is a great collision in the early days of the system, a body of considerable size striking the young planet and leaving it knocked over. It is a tidy story, and it may well be true, but it remains a hypothesis rather than a settled fact. One difficulty is the family of moons. They orbit neatly around the tipped equator of the planet, sharing the same strange angle as the world they belong to. If a large body had struck hard enough to topple everything, those moons would have to be rebuilt afterward from the debris, and the models find that outcome hard to arrange so tidily. So other explanations have been offered. One of them involves no collision at all. In that picture, the tilt grows slowly across an enormous span of time through a resonance between the spin of the planet and the patient drift of its orbit. Nudge after gentle nudge over many millions of years, the axis leans a little further. Nothing strikes the planet in this version. The world simply leans until it is lying on its side. This slower story appeals to many researchers because it leaves the moons undisturbed, carried along with the planet as it tips. Neither account has been proven. The tilt itself is the one thing we are sure of. Seen through a telescope, Uranus is a smooth circle of pale blue-green light. That color comes from methane in the upper atmosphere, which absorbs the red part of sunlight and lets the blue and green wavelengths scatter back out. There is no banded pattern to catch the eye, no famous storm watched across centuries. The visible disk looks almost blank. A haze of hydrocarbons sits above the cloud tops and softens whatever structure lies beneath it. Later observations with larger telescopes have found faint, bright clouds drifting there, so the atmosphere is not truly still. It is only quiet and very well hidden. Around the planet lie rings that are nothing like the bright bands of Saturn. They are narrow and dark, made of material that reflects very little light. They were not seen directly at first. Astronomers found them by watching a distant star pass behind the planet and noticing that the starlight blinked several times before the planet itself arrived, then blinked again in the same pattern on the far side. Something narrow and unseen was crossing in front of that star. Small moons help hold the rings in place, shepherding the particles and keeping the edges surprisingly sharp. The larger moons carry names borrowed from old plays and poems, Titania and Oberon, Ariel and Miranda among them. Because the planet lies on its side, the seasons here are unlike any other. Uranus takes about 84 years to travel once around the Sun. For roughly a quarter of that journey, the northern pole points almost directly at the Sun, and the entire northern hemisphere lives through a single unbroken day. That day lasts about 42 years. On the other side of the world, the same length of darkness runs on without a sunrise. Then the planet swings around and the arrangement slowly reverses. Between those extremes come brief spans when sunlight falls across the equator, and it is in those seasons that the atmosphere seems to stir most visibly. Even then, the light is thin. Sunlight at that distance carries only a small fraction of the warmth that reaches us here. Only one spacecraft has ever visited this world. Voyager 2 passed through the system in January of 1986, moving fast with no chance to stop or return. It had a few hours of close work after a journey of many years. In that brief window, it measured the magnetic field, counted new moons, photographed the rings from behind, and sent home the only close portraits we possess. Those pictures show a soft and almost featureless globe, blue-green and calm. The magnetic field turned out to be strange as well, tilted far from the axis of rotation and offset from the center of the planet. Everything else we know about this world has been gathered from an enormous distance. No spacecraft has been back in all the long years since. Somewhere below the clouds there is probably a deep hot layer of water, ammonia and methane, dense and slow-moving. It is sometimes called an icy mantle, though it is far too warm for ice in any ordinary sense. Above it, the atmosphere thins upward, layer by layer, until it fades quietly into the dark. And the whole tipped world goes on rolling around the sun, one long, slow revolution, the sunlit pole staring outward for decades at a time. It has completed fewer than 3 full circuits since anyone first recognized it as a planet. It has never needed to move any faster than this. Far beyond the rings of Saturn, the last of the great planets moves through a very dark stretch of space. Neptune is a deep and even blue. It is the smallest of the 4 giant worlds by width, and the most distant planet we know. Sunlight arrives there weak and thin. At that distance, the sun delivers roughly 1,000th of the light that falls on Earth. Noon on Neptune would look like a long blue evening. The color comes mostly from methane high in the atmosphere. Methane absorbs red light and lets blue light scatter back out into space. Recent studies suggest that a layer of haze also shapes what we see. Uranus seems to hold a thicker haze that pales its color, while Neptune keeps a clearer and deeper blue. Neptune was found by arithmetic before it was found by glass. Astronomers watching Uranus noticed that it kept drifting away from its predicted path. Two mathematicians working separately calculated where an unseen planet would have to be to pull it aside like that. In 1846, a telescope in Berlin turned toward that patch of sky, and the planet was waiting close to where the numbers had placed it. One trip around the sun takes about 165 of our years. Since the night it was discovered, Neptune has completed exactly one orbit. Each of its seasons lasts more than 40 of our years, so the light there changes across a lifetime rather than a year. Just one machine has ever come close enough to see it properly. In August of 1989, Voyager 2 passed within about 5,000 kilometers of the cloud tops. That was the closest approach of its entire long journey. Nearly everything we know from up close was gathered in a few quiet days. In those images, a dark oval sat in the southern hemisphere, about as wide as the Earth. It was named the Great Dark Spot. Bright white clouds of methane ice hovered above it, formed where air was lifted and froze. When Hubble looked toward the same region a few years later, the spot was gone. A new dark oval had appeared in the northern hemisphere instead. Later observations from the ground suggest that these dark ovals are not clouds at all, but darker material lying below the visible haze. This is the difference between Neptune and Jupiter. The Great Red Spot of Jupiter has been followed for well over a century as it slowly narrows. The dark spots of Neptune gather, drift, and fade within a few years. They are weather rather than landmarks. Nothing there asks to be remembered. The wind speeds were measured by patience. Researchers followed the bright methane clouds from one image to the next and measured how far they had traveled. The fastest of them move at more than 2,000 kilometers per hour. No faster winds are known anywhere else in the solar system. In the air of Earth, that speed would carry a cloud past the speed of sound. In the thin, cold air of Neptune, those winds run close to the local speed of sound. There is something strange in this. The winds are fastest where the sunlight is weakest. Neptune gives off more heat than it receives from the sun, so much of its weather is powered from within. The storms out there are not really made of sunlight. They are made of a slow warmth leaking out of a cold and enormous body. Then there is the moon. Neptune keeps a large moon named Triton, and Triton travels the wrong way around. It circles the planet against the direction in which Neptune spins. No other large moon in the solar system does this. A moon that formed alongside its planet inherits the direction of that early spinning disk. So Triton probably formed somewhere else. It resembles the icy bodies of the Kuiper Belt out past the last of the planets, and it was most likely captured long ago as it drifted near. In size and in makeup, it is a close cousin of Pluto, another world that was born far from the Sun. Triton holds one of the coldest surfaces ever measured. Its temperature sits near -235 degrees. A very thin atmosphere of nitrogen rests over it, lighter than the air above the highest mountain of Earth. Frozen nitrogen covers it like a pale glaze over a mantle of water ice and a core of rock and metal. Much of that surface carries a dimpled texture that resembles the rind of a melon, and nothing quite like it has been found anywhere else. There are very few craters. A world with few craters is a world that keeps renewing its own face. Voyager 2 also saw dark plumes rising from the southern ice. Some of them climbed about 8 kilometers before the thin air bent them sideways. The wind then carried the dark material away in long streaks across the frost. The likely engine is gentle. Sunlight passes through the clear surface ice and warms a darker layer just beneath it, and the nitrogen down there turns to gas and finds a way out. Very little sunlight is needed for that. On Triton, the sun is only the brightest star in the sky. Neptune hangs above the ice, large and blue and slowly turning, and over much of that moon it never sets at all. The light that lands on them left the sun a long while before it arrived. Out there, a blue world and a backward moon keep each other company, and neither of them has ever needed an audience. Beyond Neptune, the sunlight thins into something closer to a memory of day. Out here, the sun is still the brightest star in the sky, but it warms almost nothing. It is a sharp, small point of light rather than a disk. Noon on Pluto is about as bright as twilight on a summer evening at home. And that faint light falls on a world that took a very long time to reveal itself. For most of a century, Pluto was a smudge on photographic plates, a point that shifted slightly against the fixed stars. Astronomers argued about how large it was, and each new measurement made it smaller. Then telescopes began finding other bodies out there, in the same cold ring, moving along similar slow orbits. That ring is the Kuiper Belt, a broad zone of icy worlds beyond the orbit of Neptune. Some of those bodies turned out to be nearly the size of Pluto itself. And so in 2006 the definitions were rewritten. Pluto was placed in a category called dwarf planet, together with several other round worlds on distant orbits. Nothing about Pluto itself changed that day. The ices did not melt, and the orbit did not shift by a single kilometer. What changed was a word in a catalog written by people trying to sort a solar system that had turned out to be far more populated than they expected. The category is a filing decision, not a judgment. The world is still there, turning slowly in the dark, exactly as it always was. The belt around it is not crowded either. There may be hundreds of thousands of icy bodies wider than 100 kilometers out there, and still the space between them is enormous. No two of those bodies have ever been within sight of one another, and none of them ever will be. A spacecraft called New Horizons crossed that distance to look properly. It launched in the same year the category changed, and it traveled for 9.5 years. It could not stop or enter orbit because it was moving far too quickly to be captured. In July of 2015, it swept past and sent home the first sharp pictures of that surface. What people noticed first in the early images was a shape they recognized immediately. A broad, pale region shaped very much like a heart, sitting just below the equator. The left half of that heart is a plain of frozen nitrogen more than 1,000 kilometers across. It is called Sputnik Planitia, and the ice there is at least 4 kilometers thick. Look closely at the pictures and you will notice something missing. There are no impact craters on it. Not one anywhere across that entire plain. Everything in the outer solar system is struck eventually over billions of years, so a clean surface has to be a young surface. The nitrogen ice is being turned over from below. Faint heat from the interior sets up a slow churning motion, and the ice rises, spreads out, and sinks again in broad cells. You can see the edges of those cells in the images, a pattern of soft polygons tens of kilometers wide. The turnover takes something like 500,000 years, which sounds slow until you set it beside the age of the solar system. By that measure, the ground you're looking at may be younger than our own species. Around the edges of the plain stand mountains. They rise a few kilometers above the surrounding terrain, comparable to the higher peaks of the Rocky Mountains. At those temperatures, nitrogen ice is soft, closer to warm wax, and could never hold such a shape. These mountains are made of water ice. That far from the sun, water ice is hard and brittle, strong enough to hold a mountain up for billions of years. East of the plain, glaciers of nitrogen ice flow down from the highlands through valleys and spill out onto the flat white floor. As the spacecraft passed on, it turned and looked back at Pluto against the sun. The thin atmosphere lit up from behind, revealing more than a dozen layers of blue haze reaching high above the ground. That haze is built by sunlight out of methane and nitrogen, tiny particles drifting slowly downward for years before they settle. New Horizons kept going after that deeper into the belt, while the mission team searched for another target. They found a small object more than 1 billion kilometers further out and named it Arrokoth. On the first day of 2019, the spacecraft passed it. Arrokoth is 2 lobes joined together, a large flat one and a smaller one meeting at a narrow neck. It looks a little like a snowman, reddish in color, about 35 kilometers long. The 2 lobes came together slowly, at walking pace or gentler, and simply stayed. Nothing was shattered in that meeting. It is the quietest kind of evidence for how the first solid bodies grew, by settling against each other rather than by violent impact. Arrokoth has been out there in the cold since the beginning, holding still, waiting without changing. And beyond it, the belt continues, thinning gradually with no fence and no edge. On a printed chart, the solar system looks almost crowded, with the planets set in a tidy row and each one a comfortable step from the next. That picture is a convenience rather than a portrait, and it exists only because the truth will not fit on a page. The real arrangement is mostly absence. Take away the worlds themselves and almost nothing remains, only a long and quiet dark that no diagram has ever managed to show honestly. Begin with light, because light is the only ruler long enough for this work. Sunlight reaches Earth in about 8 minutes and 20 seconds, and that is the shortest of all these journeys. The same light needs roughly 43 minutes to arrive at Jupiter, and about 1 hour and 20 minutes to touch the rings of Saturn. Uranus waits nearly 2 hours and 40 minutes for it, and Neptune receives it after more than 4 hours. Nothing in the universe moves faster than that. Even so, the outer worlds wait through an entire afternoon for the light that leaves the center of the system. Shrink everything, and the shape becomes easier to hold in the mind. Change the scale a different way, and measure the system in footsteps instead. If one slow walking pace stood for the distance from here to the Sun, Jupiter would be 5 paces off, and Neptune would be 30 paces down an empty corridor. Jupiter would be a modest marble some 56 meters from that table, and Neptune a small seed lying more than 300 meters off. Between those specks there is nothing, not one solid thing across the whole span. The planets rarely line up, and even when they appear to, hundreds of millions of kilometers still stand between them. The emptiness is not perfect, of course. The space between the worlds carries a thin wind of particles streaming outward from the Sun, along with dust ground away from comets and from slow collisions in the belt. It carries a magnetic field as well, dragged along by the star like an invisible fabric that never quite lets go. But by any ordinary measure, it is nothing at all, since a cubic centimeter of interplanetary space near Earth may hold only a few particles. The finest vacuum ever built in a laboratory is crowded by comparison. This emptiness is why travel takes so long. A spacecraft cannot simply point itself outward and press ahead, because it must fall into an orbit, borrow speed from the planets it passes, and then wait. Cassini left Earth in 1997 and did not settle into orbit around Saturn until 2004. On the way it swung past Venus twice, then past Earth, then past Jupiter, gathering a little momentum from each encounter. That is 7 years of travel toward a destination that light crosses in 80 minutes. Voyager 2 departed in 1977 and passed Neptune in the summer of 1989, which is 12 years of coasting for a few hours of close encounter. New Horizons flew faster than any probe before it, and still needed 9.5 years to reach Pluto. Its whole meeting with that world lasted less than a single day. The people who built these machines spent much of their working lives simply waiting for them to arrive. Some of them retired before the pictures came home. Distance stretches conversation as well, since radio waves travel at the speed of light and no faster. A command sent to Voyager 1 now takes more than 20 hours to arrive, and the reply takes just as long to return. Every exchange with that spacecraft is a 2-day conversation, carried one patient sentence at a time. Engineers write their instructions and go home, knowing the answer will arrive while they sleep. Both Voyagers are still out there far past the last planet, coasting through a dark that no longer holds anything close enough to see. Where the reach of the sun finally gives out is a longer question, and it can wait until later tonight. They left the bubble of solar wind, which is a real and measurable frontier, but the reach of solar gravity extends very much farther than that. Far beyond both spacecraft, the dark simply keeps going, and nothing out there marks their passage. Whatever waits at the far outskirts of this system is still ahead of them, and still ahead of us tonight. There is no gate out there, no line drawn across the dark, no moment of departure. The solar system does not end so much as slowly thin away. Both spacecraft are falling outward tonight, carried by speed they gathered from giant planets decades ago. Their instruments run on a source of warmth that fades a little every year, and in time there will not be power enough to send anything back. They will keep going regardless, silent and unhurried, along a road with no far shore. Think of them for a moment, 2 small machines older than most of the people who follow them now. The dark between the planets asks nothing of anyone, and it never has. It is only distance, patient and enormous, holding every bright thing gently apart. Somewhere inside it, a probe is drifting, warm at its core, still counting the few particles that pass. Nothing out there is in any hurry. Neither tonight is anything inside this quiet room. Somewhere in the sky tonight, a star is being born. You can point a telescope toward it and watch the beginning happen. Around that young star lies a flattened disk of gas and dust, turning slowly, glowing faintly in the cold. Telescopes in the high desert of Chile have photographed many such disks, and inside them we see bright rings separated by quiet, dark lanes. Those lanes are very likely the work of young planets, sweeping their paths clear as they grow. So these are not only pictures of distant worlds, they are pictures of our own beginning, arriving a little late. Our story starts with a cloud. Between the stars drift enormous clouds of hydrogen, helium, and fine grains of dust, colder than almost anything you can imagine. Every atom heavier than helium in such a cloud was made inside earlier stars and released when those stars came to their end. A cloud like this can wander for millions of years without doing anything at all. Then something disturbs it, perhaps the slow pressure of nearby starlight, perhaps a wave passing through from a star that has finished its life. One region becomes slightly denser than the rest, and that small difference is enough to begin everything. Gravity pulls a little harder where there is a little more matter, and the crowding feeds on itself. The dense core contracts, and as it contracts, it grows warmer. The cloud was never perfectly still. It carried a faint and almost accidental rotation, so slight that you would never notice it. As the core shrinks, That rotation speeds up in the same way a spinning skater turns faster by drawing in the arms. Now the gathering material cannot fall straight inward from every direction, because the spin throws it outward along the middle. So the collapsing cloud flattens. A sphere becomes a disk, and the disk keeps turning around a thickening center. That center becomes the sun. Most of the matter falls into it, and when the core grows hot and dense enough, hydrogen begins to fuse and the new star begins to shine. Everything else, a small fraction of the original cloud, is left circling in the flat sheet around it. Every planet, every moon, every stone came from that thin remainder. In the disk, the building starts small. Grains of dust, each one finer than smoke, drift and touch and cling to one another through simple static attraction. Clumps the size of a sand grain become pebbles. Pebbles gather into boulders, and boulders become bodies wide enough to hold themselves together by their own gravity. Those bodies are called planetesimals, and once they exist, the process quickens. A larger body pulls harder, so it collects more, and the more it collects, the harder it pulls. Growth rewards whatever is already large. Where you sit in the disk decides what you have to build with. Near the young star it is warm, and water, methane, and ammonia remain as vapor, thin and difficult to hold. Only rock and metal survive there as solids, and rock and metal are rare in a cloud made mostly of gas. So the inner worlds grew slowly and stayed modest, and Mercury, Venus, Earth, and Mars are the result. Farther out, past a boundary astronomers call the frost line, the temperature falls low enough for water to freeze. Beyond that line, there is far more solid material to work with, because ice is abundant where rock is scarce. Cores grew quickly in that region, and once a core became massive enough, it began to draw hydrogen and helium directly from the disk around it. That is how Jupiter and Saturn became giants, by gathering gas while gas was still there to gather. Uranus and Neptune formed later or more slowly, and collected less of it before the supply thinned away. Each growing giant gathered a small disk of its own, and its large moons were built inside it, which is why they orbit so neatly. The disk itself did not last long by the standards of these things. Within a few million years, the young sun pushed the remaining gas away with its light and its wind. Whatever was unfinished stayed unfinished. The bodies between Mars and Jupiter never assembled into a single world, and they still circle there, scattered thinly across an enormous volume. The icy fragments of the outer dark were never gathered either, and they simply remain where the building stopped. You can still see the shape of that disk in the sky today. The planets travel in nearly the same plane and in the same direction because they inherited the turning of the sheet that made them, and they have kept it ever since. And this is why those distant disks matter to us. We cannot travel back to watch our own beginning, so we watch other beginnings instead, hundreds of them at every stage. Some are smooth and featureless, newly formed, while others show wide gaps where something unseen is already clearing a lane. A few are nearly empty, their gas spent, their planets finished and quiet. Laid side by side, they form a sequence, and that sequence is a kind of memory. When you look at one of those faint rings, you are looking at a photograph of the room you were made in, taken somewhere else, long after the fact. The same slow settling that shaped those rings shaped the ground beneath you. It began with cold dust, drifting in the dark, waiting to touch something. Every so often a faint smudge of light appears far beyond the planets, drifting slowly against the fixed stars. It has come a very long way to be seen. Some of these visitors have been falling toward the sun for millions of years, and this will be their only pass. Astronomers trace their paths backward and find something quiet and strange because the long travelers do not arrive from any single direction. They come from above the planets, from below them, from every side at once. That one fact tells you a great deal about the place they left behind. The planets move in a broad, flat disk, all of them turning in roughly the same plane. But the comets with the longest orbits ignore that plane entirely, so their home cannot be a disk. It must be a shell, a vast faint sphere of frozen bodies wrapped completely around the sun, so distant that no telescope has ever imaged it. We know it the way you know a dark room, by what comes out of it. A Dutch astronomer named Jan Oort worked this out in 1950, using nothing but the orbits of comets and a great deal of patience. The cloud has carried his name ever since. Try to hold the scale of it in your mind for a moment. The inner boundary of this cloud may begin a few thousand times farther from the sun than the earth is. The outer reaches may extend 100,000 times farther than the earth, which is more than a light year and a half. Between those two figures there is no shore, no threshold, and no place where the solar system officially ends. There is only a slow thinning. The icy bodies grow rarer and more scattered the farther out you go, until at some point there are simply too few of them to call it anything. This is the part that is hard to picture. The cloud may hold 1 trillion objects or more, and still no two of them have ever passed within sight of each other. Spread that number across such an enormous volume, and the typical distance between one icy body and the next is thought to be greater than the gap between the Sun and Uranus. If you stood on one of them, you would see nothing nearby. The Sun would be a bright star rather than a disk, and it would give you no warmth. Everything else would be darkness and the slow drift of the galaxy. The whole cloud together may weigh only a few times as much as the Earth, and most of a solar system, it turns out, is empty room. Now think about what stirs it. Out there, the grip of the sun is gentle, and gentle things can be nudged. A star passing within a few light years, over millions of years, tugs at the outer bodies. The slow tide of the galaxy itself pulls on them as well, and it takes almost nothing to change an orbit that faint. One small nudge, and a body that has circled quietly for ages begins to fall inward. It falls for a very long time. Then, one night, someone on Earth notices a smudge of light that was not there before, People sometimes say that a spacecraft has left the solar system. Voyager 1 crossed the heliopause in 2012, and that crossing was real and remarkable. It marks the place where the wind from the sun finally gives way to the thin wind between the stars. But that is the edge of one particular thing the sun does, not the edge of the sun as a place, and gravity reaches much farther than the solar wind. Voyager 1, the most distant thing we have ever launched, would need roughly 300 years just to reach the inner cloud. Passing all the way through the far side would take something like 30,000 years. It will be silent long before then, drifting quietly among bodies it will never see. And beyond even that, the fading continues. Proxima Centauri, the nearest star to us, lies a little over 4 light-years away. The Sun holds gravitational authority over perhaps 1 or 2 of those light-years, and somewhere past that its influence quietly gives way to other suns. The two territories do not meet at a fence. They blend into each other. There is no moment of crossing, and no last stone of ours, only a long soft region where one claim weakens and another slowly grows. It is worth sitting with that idea, because it is unusual, and almost everything else we know has an edge. Rooms have walls, countries have borders, and days have an end, while the solar system has none of these. It is not a room with a door, but a light that dims outward, a gathering that grows sparser, a place defined by its center rather than by its rim. So the map simply runs out, not at a barrier, but in a soft fade, the way sleep arrives without a border of its own. And out there tonight, farther than any of it, a small mountain of ice turns slowly in the dark. Its year is longer than our species has existed, and it has never once been warm. It may never fall inward at all, and if it does, no one alive now will be here to see it. It just keeps going, patient and unbothered, in the wide quiet where the solar system does not so much end as forget to continue. Nothing out there needs you to be awake for it. The system keeps its own time, and it keeps it well. Mercury is turning slowly through another of its long days, carrying its bright side and its dark side around with it. The ice resting in its shadowed craters is not melting tonight. It has waited there for ages, a few steps from stone hot enough to soften metal. Venus is holding its warmth under a thick and even blanket of air. The heat there does not rise or fall between afternoon and midnight. It simply stays the same everywhere, hour after hour. Mars is cold and dry and very still. In one wide crater, a river once spread out and set down its layers, and those layers are lying exactly where the water left them. Nothing has hurried them since. Beyond Mars, the belt is drifting, and it is mostly empty space. If you stood on one stone there and looked up, the sky would be dark and quiet and nearly bare. The neighbors are millions of kilometers away, going about their own long orbits, in no danger of meeting. It is the emptiest crowd ever imagined. Jupiter is turning under its bands, and the bands are moving the way they always move. The great storm is still there, rounder now than it once was, breathing in and out on its own slow schedule. Io is glowing somewhere along its orbit, warm from a pull it cannot escape. Europa is carrying an ocean under its shell, dark and salty and undisturbed. Saturn is leaning into its rings, and the rings are made of ice and light. Grain by grain they are falling home so slowly that the falling looks like stillness. You are alive during the part where they are still bright. Enceladus is breathing its fine salt spray into the dark, and the spray freezes and drifts and settles back down as snow. Titan is under its orange air, where the rain is not water and the stones are not stone. A slow river is running somewhere on it tonight, filling a sea that will still be there in the morning. Uranus is lying on its side, going around as it always has, for reasons nobody has settled yet. Neptune is deep blue and far away, with fast winds pushing bright clouds across its face. Triton is circling backward, quietly against the direction of everything around it. Somewhere on its frozen skin, a thin plume of nitrogen is rising into a nearly empty sky. Pluto is out past the last of the planets, small and cold and complete. Its wide heart of nitrogen ice is turning over from below, one slow cell at a time, smoothing itself as it goes. That ground is younger than the words we use for it. Past Pluto, the lanes thin out. There is no wall and no gate and no last stone. The sun keeps letting go of its light, thinner and thinner, until other light takes over without any ceremony. Far beyond that, in the dark, a great loose cloud of ice is holding still. Some of it has barely moved since the beginning. All of it is falling around the sun anyway, in orbits so wide that a single turn takes longer than our whole species has existed. Nothing needs to be finished tonight. The whole arrangement is simply falling, each thing around something heavier. That is all gravity ever asks of anything. Fall and keep missing, and come back around. You are riding one of those curves right now. The ground under you is moving, and you cannot feel it, and that is exactly how it should feel. The room you are in is riding a planet that is riding a star. The star is riding a slow arm of a galaxy. None of it is loud, and none of it requires your effort. Let your breathing get slower than your thinking. Let your shoulders come down and stay down. The turning does not stop when you stop paying attention to it. It never has, and it never will. Mercury will finish its long turn. The ice in the shadows will hold. The rings will keep falling like a soft snow that takes 100 million years to land. The storm will keep breathing in and out. The ocean under the ice will keep its temperature, and no one will look at it, and it will be perfectly fine. Somewhere a methane river will reach its sea and go quiet. You can put every one of those worlds down now, the hot ones and the frozen ones alike. They will go on without being held. Everything is where it belongs, and all of it is still moving. You are somewhere warm and small inside that, which is a good place to be. Let the numbers and the names and the distances go. They were never yours to carry. Keep only the turning and feel how steady it is under everything. Feel how little it asks of you. Rest now and let the rest of it carry on without you. It has had excellent practice. Every world is on its curve. Every ring is drifting down. Every hidden ocean is calm beneath its lid of ice. The sun is holding all of it together with nothing but patience. And you are turning too, once around, slowly, while the night goes on being long and ordinary and safe. Sleep well now and let it turn. Everything out there is still turning. It will still be turning when you wake.